For number 19, we're looking at graphing an absolute value equation. I'm going to graph this based on identifying where the vertex is and then using the slope to help me with that. First piece of information I know, the vertex has an x-coordinate. Let me actually put this on pen, of whatever makes the inside of this equal to 0. So 0 would be my x, and the y-coordinate is whatever we're subtracting at the end. 0, -1 would be my vertex. So vertex. From here, I'm going to use -3 as my slope, so I'm going to go down 3, 1, 2, 3, and over 1. There's the right half of this. The left half of this is going to be going back 1 and down 3. And I get an upside down V with a relatively steep slope. For number 23, we're solving this by elimination. And what we really need to do is to get one of these variables to have the same coefficient. It doesn't matter which one we go for. I kind of like the idea of going for, I don't know, x in this case. So I'm looking for a way to get both 6 and 5 to be the same number. And to do that, I might multiply the top by 5. And I might multiply the bottom by 6. The top becomes 30x plus 30y is equal to -30. And the bottom becomes, let's do -6 instead so we can add these, -30x minus 24y is equal to 0. When I add these together, my x's cancel out. I end up with 6y is equal to -30, which means that y is equal to -5. When I plug this back into one of my equations, I don't know, let's go for the first one. So 6x, and if y is -5, minus 30 is equal to -6. If I add 30 to both sides, we end up with 6x is equal to 24, and x is equal to 4. Solving by substitution. I probably would not actually solve this by substitution, but I might as well remind us what we're looking for, because these are going to be some unpleasant numbers. First thing I might do is to add 4y to both sides. Nothing is divisible here, so there's no better way to do this. And divide by 3, and that would give us an equation with x is equal to 4y over 3 minus 19 over 3. When I plug this into my bottom equation, we get 7 times 4y over 3 minus 19 over 3 plus 5y is equal to 13. Distributing, we end up with 28y over 3 minus, and that's going to be 70 and 63, 133 over 3 plus 5y is equal to 13. I don't love these denominators. I'm going to multiply this whole equation by 3 to get rid of them. And we end up with 28y minus 133 plus 15y equals 39. All right. Here we end up going with 28 plus 15 is going to be 43y. I'm going to add 133 to the other side. We end up with a 163 plus 9 is 172. And this happens to divide really nicely to get us y is equal to 4. If I plug that back into the only equation I can see, actually I can have a better equation up above. Maybe not. The only equation I can really see at that point would have been 7 times x plus 5 times 4 is equal to 13. And if I solve this, I should get x is equal to -1. Plugging that into the other equation just to make sure that works. Because I don't trust myself right now, we get negative 3 minus 16 is negative 19, and that makes me very happy that that worked out. Okay, we're talking about a plane traveling to Dar es Salaam and back. Trip there was with the wind, it took 7 hours, and the trip back was into the wind and took 14 hours. What this really is a rate times time is equal to distance problem. And the trick here is to remember that going to Dar es Salaam and coming back are going to have the same distance. So we're going to have a rate times time for going there is equal to some kind of a rate times time for coming back. We don't know what the rates are because we're going to have both a rate for wind speed and for the plane speed, but we do know what the times are. So we have rate 1, which is going there, is 2 times 7 hours, and that's going to be equal to rate 2 times 14 hours. Okay? The first rate is going to be, I'll call it plane, and this is with the wind. That means both the wind and the plane are going in the same direction. What that means is that we add the wind and the plane speed to that. So we get plane plus wind for my rate times 7. And on the way back, we're going to have, if they're going in opposite directions, we're going to subtract plane minus the wind times 14. Okay, so this is going to be 7p plus 7w is equal to 14p minus 14w. Let's take a look to see if there's anything else in the problem. Oh, I missed the 700 miles part. That's helpful. So rather than set them equal to each other, which is going to end up with something that's not all that helpful, what I might try is taking a step back and rewriting this because I did not read that 700 part. So 7p plus 7w is equal to 700, and 14p minus 14w is also equal to 700. I'm going to simplify these equations to start off because these are not pleasant numbers. So p plus w is equal to 100. And if I divide both of these by 14, we get p minus w is equal to 50. If I add these two equations together, I get 2p, the w's cancel, and 150, which means that p is 75. And the only way this works is if the wind speed is 25. For number 28, we're looking at the sum of the digits of a certain two-digit number is 11. Let's call this number xy. That means that we've got x plus y is equal to 11. The number itself, if this is the number xy, would really be 10 times x. That'd be our tens place, plus y. And it says that reversing the digits increases the number by 45. So if I do this, this is the original number, plus 45, that gives me the reversed digits. So instead of 10x plus y, we're looking at 10y plus x. Okay? I can go a little bit further and rewrite this as y is equal to 1 minus x, and by 1, that should be 11. So when I plug that in, we get 10x plus 11 minus x plus 45 is equal to 10 times 11 is 110. 10 times minus x is minus 10x, and plus x. Let me just get rid of some of the stuff down below for a second. Bear with me. me so I can make some more room. We don't have a good way to erase things on here that are already there, so we just write over them in white marker. Okay. If I combine everything to one side, we're going to add 9x to 9x, and we get 18x plus 11 plus 75, plus 45 is going to be 56. And I've got 110 minus 56 would be 54, which gives us x is equal to 3. And if that's true, that means y has to be 11. That means that y has to be 8 in order to make 11. That means our original number is 38. We've got a system of 3 equations with 3 variables. In looking at this, I happen to notice that all of the c's have the same coefficient, with differences plus or minus. And that may make a good argument to get rid of c first. When I add my first 2 equations together, we end up with negative 5a, negative 4b, and 0 is equal to negative 6. And if we go to add our first and third equations together, that'll give us negative 7a, that'll give us negative 7b, and that will get us 0. I might then divide both of these by negative 7 just to make this a little bit nicer. And that turns into a plus b is equal to 0. Okay, I still need to get rid of a and b, or a or b. And to do that, I might say, okay, well, b and negative 4b, I can multiply this guy by 4. And I get 4a plus 4b is equal to 0. So then when I add these together, it's negative 5a minus 4b is equal to negative 6. My b's cancel out, I'm left with negative 1a is equal to negative 6, which means that a is equal to 6. Okay? I know that a plus b is equal to 0, so that means that b has to be negative 6. The number, or the equation up here that has the smallest stuff seems to be the middle. So negative 3a, negative 3 times 6 is negative 18. b is going to be negative 6, plus 6c is equal to negative 6. Okay, I'm going to combine some things and move them to the other side. So that's going to be negative 18 plus negative 6 is negative 24, plus negative 6. I'm going to add 24 to both sides, leaving me with positive 18 is equal to 6c, which means c is equal to 3. For number 31, I've got kind of a weird system in that I don't have all the pieces all the time. I've already gotten rid of a in the second equation, so maybe I'll just kind of get rid of a in one of the other ones, and I might combine these through subtraction to do that. So when I subtract those, we end up with negative a minus negative a is 0. Negative 2b minus negative 4b is going to be 2b. c minus 2c is going to be minus 3c is minus 2c. And negative 3 minus negative 1 is going to be negative 2. Again, I kind of like dividing everything by 2 here to make this a nicer equation, which is b minus c is equal to negative 1. And if I combine that with b minus c is equal to negative, oh, that's interesting. So if I were to subtract these things, I get 0 is equal to 0. I didn't know I was going to end up with something like this, but because I combined these 2 equations, and basically they gave me this third equation. This would be something that we have an infinite number of solutions. This is a true statement, and if we have a true statement, we have an infinite number of solutions. What this really means is that one of these planes overlaps the other planes. Moving on to systems of inequalities, we're going to graph this. I'm probably going to get y by itself, and that's going to turn into y is less than or equal to negative 11 over 4 x and plus 3. So there's my 3. Negative 11 over 4 is going to be something like that. A nice line through those points. And if y is less than or equal to, that's going to be on this side. Okay? For my other one, I'm going to do the same thing. Get y by itself to make it easier to graph. And y is going to be greater than or equal to. That's going to be positive 3 over 4x. And then minus 5 when I divide 20 by negative 4. So we're at minus 5, up 3 to minus 2 over 4. And we're greater than, so we're going to color in the top of this. The part that overlaps is going to be this region up here. And it's nice to me on a spiral if you show me that region very clearly. And that's all she wrote. All the solutions are here. There are 6 problems without any solution or that have an infinite number of solutions. But going through these should give you a pretty good idea of how comfortable you are with different topics and give you some idea of how to ask for help on things that you don't know.